Hello, good morning, students. Welcome to today's class, which is based on the concept of one of Python's, or should I say, one of programming's most interesting ideas called random. Now, in the next few minutes, I will try to explain to you the beauty of this random, how important it is to programming, how importantly it brings programming close to reality. And that is where we will begin to understand the place of Python in programming and the chase between programming and reality. Random seems like a very simple concept. My question now is, what is random? When we say random, anything could be random. The falling of leaves from a tree, the movement of the grains of sand on the beach, the juggling of coins, the movement of molecules in the wind. There are many random things in the universe, in the world, on earth. But you see, reality is truly random at a scale that the human mind cannot redo or recreate or reproduce unless we use reality itself. For example, if I put two stones in a container and seal them, and I continue to shake them and use a laser to measure their orientation, I will realize that those stones will continue to be random at an infinite level. Now, it is important that we understand the meaning of the word infinite in this case. It means for eternity, we will always find a new orientation that we have not seen before. Who knows, maybe the stones will break. If you decide to take a picture of the surface of the ocean, the roughness of the surface of the ocean as the wind moves, you will continue to see more and more and more and more and more impossible patterns. This is where reality becomes too rich for generative AI or for recreation. But we are beginning to look towards quantum computers to see if quantum computers can give us the needed randomization to capture reality. Now, if truly randomization is so complex, what kind of randomization do we then have in computers? Because there are many times you play games that pretend to be random, right? A lot of games. Now, the question is, inside a computer, can something be random? The answer is no. It is impossible to redo the randomization of reality inside a computer. And that is why inside the computer, we call it pseudo-randomness, or the word pseudo-random. A pseudo-random structure is a structure. It's just like when you say pseudocode. It's not really code. It's just something that feels like code. So when you say pseudo-random, it's not random, but it feels so close to random. So imagine you are dealing with an object that's supposed to be changing to give you infinite values in reality. And you want to recreate that into computer. Infinite is impossible in the computer. There are so many ways of gaining the infinite in computer. You could use the extension of the decimals of pi to make your randomization. Now that could be infinite, but that will break your computer. Yes, because true infiniteness has unlimited size. So imagine pi with 10 billion numbers in front of it. By that time, your computer would have broken. So you see the problem. So to get a real random number, or should I say something close to reality, we created the pseudo-randomness. Now, pseudo-randomness is generated by mathematical structures. It's quite close to randomization in reality, but it is not exactly randomization, but very close. Now, for those of us listening on YouTube, if you want to reach out to us, our number is 081-3662-8035. You could reach out to us and join our classes so that you can take advantage of the tools that you see us using in this video. The tools are on our platform. When you join us, we register you on our platform and give you access to our programming tools and our classes so that you're beginning to develop your journey as a programmer in Nigeria. Thank you. Back to the class. All right. So that is what pseudo-randomness is. Now, pseudo-randomness is a scenario whereby something is almost random, but is not. For example, if we take an object, or should I say a process, that does not repeat itself for 10 million cycles, to your human mind, this will look truly random, because there is no way you wait to generate 10 million different values, and by the time it repeats itself, you cannot remember the original value anymore. So this is called pseudo-random. Randomness, that non-randomness, or cycles that don't repeat, whose range is so large that the human mind cannot grasp completely its beginning and its end. And such a cycle, as long as it does not repeat within itself, can be called pseudo-random. Is that clear? Now, this is going to govern our use of randomness in Python. All right. The next thing we want to do is to look at the randomness in code. In code, when you talk of randomness in Python, we have to talk of one thing before we talk of randomness, because randomness takes us to modules. So I'm going to talk about modules in this class, and we'll see how far we can go about randomness, because I don't like jumping topics. I like us to pursue things one step at a time correctly. And we cannot talk of randomness in code without talking about modules in code. So I'm going to talk about modules now. And when I'm done, if our class is not overspent, then we will talk about, we'll continue the randomness class. If not, we are going to break the class into a part 1, part 2 structure. So let's talk about modules. In Python, there are 3. So first, what is a module? A module, M-O-D-U-L-E. A module in Python is simply a package of a completed programming idea, a packaged programming function. Let's put it that way. A package programming function. That's a module. Something, code that has already been written by someone else has been packaged together so that you don't have to write that code again. It has already been written and tested by someone else. So you yourself don't have to write that code again. You can just call the function into your environment and use it as if the code already exists, because it does. Now this is what we call a module in Python. For example, instead of me to start teaching Python how to do square roots, I can call the math module in Python and do math.squareroot, and the system will run the square root protocol. Instead of teaching Python how to do maybe extraction of many things, maybe extraction of decimals, I can create a module and save it in my Python, and then the Python can then do whatever it likes with the extraction of decimals. Is that clear? Okay. Now, when you think about a string of modules and being called, the question that comes to mind is, where are we calling this module from? Because it has to be saved somewhere. If it's a already prepared Python code and I want to use it, of course it has to have been saved somewhere. The place where it is saved in your Python structure is called site packages. Site packages. And when we get to advanced coding, web development, and data science for Python, we will begin to look at, in some cases, creating modules, putting them into the site packages so that we can call them later for use, especially if such a module is of divine interest to whatever program we are trying to run. That is quite important. All right. So when you call a module, where are you calling it from? You are calling it from the site packages. The question now is it every module that is stored in the site packages? The question is no. And if the module is not stored in site packages, how do you get it into the site packages? Through a process called installation. You install the module. When you install it, the module comes from the internet and goes into your site packages. All right, let's leave that aside. Let's now talk about how do we, it's one thing to know where the module is and call the module into use. But the process of calling the module to use in your code is called initialization. Initialization. So the question now is, what is initialization? And how does initialization now begin to determine the types of modules that we have? This is our most important question right now. So we begin to deal with the concept of initialization as we go along. All right. So let's deal with that. When we say initialization, we are talking about the activation of the code in our environment, of the module in our environment. The activation of the module in our environment. And that is what we mean when we talk about initialization. Deactivation, not deactivation, D-O-T-H-E, deactivation of the module in our environment. Now, it is because of this that we have three different modules. There is a module that has already been activated once you start your Python environment. Once you enter your IDE, the module is already activated. So you can just use it in your code straight, like type command that we used to know the type of a data set. You can check our previous classes if you are confused on what type command is. That is an example of a module that is already initialized. Print, for example, is also an example of a module that is already initialized. So you just call them and use them in code. You don't need to call them, just use them in code. So this is activated modules. They are activated as you start your IDE. The second set is imported modules. Imported modules. These ones exist in your site packages, but without importing them, they cannot be used. Probably not to increase the weight of the program at the point of initialization, because not everybody uses the same modules. So if you just activate all the modules and someone is not using it at all, for example, somebody who is just trying to write a program that does not involve type, and you have activated and so many things like that, all of them, then there'll be a problem. It will be too heavy and too difficult for the computer to process. So imported modules are modules that they come with your Python. As you are installing Python, they are there. But if you do not activate them, they will not come. So to activate them, you have to import them. Random is an example of an imported module. Random exists in Python. As you are installing your Python, you don't need to install it, it's there. But you cannot use random unless you import it into your file or into your IDE. All right, let's talk of the third set. The third set is called installed modules. Now, these ones are not in your computer. They are outside. So before you can talk of even using them, the first thing you must do is you must install them from the internet into your site packages. And after that, they will not be activated with your system. You must then import them before you can use them. So this is why we say installed modules must be imported. Must be imported. Without that, nobody is able to have access to them. That's about that. So these are our cases for types of modules, and random falls under imported modules. So if I want to use random in my code, I must import it. Now I'm going to take us to our IDE on our platform, and we are then going to look at, so let's go to the code editor. We will look at the use of random. So let's say I want to use random and I don't want to import it. I want to pretend as if random is not an imported variable, it's an activated variable or module. It's not an imported module, it's an activated module. And I just want to use it. Why? Because I'm God. All right, let's go ahead. I say print random.random. Sorry, my keyboard is stuck on capitals. You don't use capitals in your code. All true. Unless the module name or your variable name contains a cap, whatever. So print random dot random. Now we are going to be talking of the things that random can do one by one. Are you getting me? So the first and most important one is random dot random. We will test it now. When we get back to our whiteboard, I will explain what it does. And then we have to take this to the next class, to part 2, because our class already exceeds 20 minutes. And we're always trying to stay below the 20 minutes radar. All right, print random dot random with a call brace in front of it. What happened? It gave us an error. What did he say? He said name. You can see the error is at the bottom. Always look at the bottom to get your error. This one is explaining where the error comes from. You can see Python error traceback, most return strength call last. It's telling you that the last thing that was called, because the error will always be generated based on the last thing that the compiler tried to compile. And once that last thing fails, that is where the error will be generated from. So it says that traceback, most return call last. File is telling you the file, the code name, and where it comes from. This is the part of the code that is inside the site packages. It's showing you where it failed, and it's now telling you that name random is not defined because we don't know what random is, because it has not been activated. I can say random equals 2 or 3. It will just be a variable. Do you understand? So in order to use random, I must import random. So let's import random now. Import random. Now let's run our code again. It gave us an answer now. Can you see? Let's run it again. A different answer. A different answer. This is what is called random. So random dot random simply gives you a random number between 0 and 1 with, let's see how many decimal places, because it's fixed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 decimal places, or 16 thereabout. I didn't count it well, but 16 or 17 decimal places. So you can imagine, it gives you a random number between 0 and 1 to the specification of 16 decimal places. Isn't that amazing? Isn't that just amazing? All right. Okay. So in the next class, we'll be talking of the attributes of random, one after the other. Is that clear? The attributes of random. Okay? And as we talk about the attributes of random, we'll be talking about other things alongside with it too. But we're talking of the attributes of random. Okay? All right. So now, for this class, your classwork is simply generate random numbers between 100 and 200. I want to know how you manipulate your way. You can use this to generate those random numbers. Use this also to generate random numbers between 10 and 20. Use this also to generate random numbers between 5 and 6. All right, 100 and 200, 10 and 20, and 5 and 6. You must generate 10 random numbers each between these numbers. So write your Python code and make it work. All right, that's the classwork. Okay. You can do it. You cannot do it. Remember, if you cannot do it, just wait until the next class. We will always do the assignments in the next class. And if you cannot do it, you can message us personally on our number on WhatsApp or anywhere, and we'll be glad to answer that question for you. Thank you very much for being a part of this class. It's a pleasure to have been your instructor. My name is Ayo Gbadibo. It's